Hi, welcome. This is the first class for ETEC2110, which is systems programming. And we're going to do a few things today. We're going to go over the syllabus. We're going to then dig into some of the material, at least at a fairly rudimentary level. And I'm going to try to divide this lecture up into a couple different segments so it makes it a little easier to watch. But to get started, let's go ahead and go over the course syllabus. So first off, welcome to systems programming. Some of you may have had my classes before, some of you may have not. So let's go ahead and just jump over and get started with item number one, looking at the syllabus. Along the way, I'm going to talk about my teaching philosophy, and then we're going to dig into a little bit of systems programming. What does that mean? What is it? And there's going to be some of that mixed into these other things as well. So let's go ahead and get started. So let's start by taking a look at the syllabus. So looking at the syllabus, I'm going to switch over to the display for that. All right, so here's the syllabus. And first thing, this class originally was scheduled to be kind of a hybrid model, meaning that I would be doing some of it face-to-face, would be doing some of it remotely. But as things have turned out due to the ongoing pandemic and things not really settling down, we're going to start things out as mostly online or entirely online, meaning that the lectures will be through videos. And I don't really like that. I know a lot of you probably don't like that. It makes it a lot more isolated, and it feels strange. It's like a television show rather than a discussion. And I would prefer to have face-to-face classes, but I think we can make this work this semester by doing these through videos. But it's going to require a little bit more activity on your part, being actively involved with, if you have questions, ask me. If you need to set up a meeting and come to office hours, I can certainly come down to the university anytime and we can meet. Just make sure to wear a mask. We can go in a classroom. We can discuss, we'll put things on the whiteboard or go to my office and discuss things. So make sure if you are struggling, if you have problems, do that. The other thing that's going to be a little different about this class is that I'm going to have periodic quizzes and check-ins to make sure that I can get a sense of what you're doing. We're also going to have assignments. We'll talk more about those here in a second. But the main thing here I want you to be aware of is that there's always help available. I'll always do what I can to help. And we'll get through this kind of strange semester together. All right, so first thing on this class is systems programming. And maybe you know what that means, at least at some level, but we're going to talk about that here a little bit today. Section 1 is Tuesday and Thursday, 2 to 4:15. Section 51, evening section, Tuesday and Thursday, 5 to 7:15. And I have these places listed on here, but we're really only going to meet there when we have our exams, unless something changes that makes it so much safer for everybody, for you and your families. So for the most part, what I want you to do is at the times of the class, go to the course page like you would go to the class, watch the videos. If you have questions that come up, email me, send me a message, text message, give me a phone call. But try to keep that class schedule. So in other words, don't let it slide and wait until several weeks go by and then try to binge watch all of it. It's going to work better if you kind of give yourself time to absorb it, take the quizzes, do the assignments, and do things that way. So try to observe those things. We may have some of the lectures that are actually not video delivered or recorded, that are done live on Blackboard Collaborate. So just try to go to the course site at the time. There'll either be a video of the lecture or there'll be an assignment with instructions. And a lot of times, even if there's an assignment, I'll still have a video explaining the assignment and so forth. But try to go there at the time, look at the new stuff. Any quizzes that are on there, any assignments that are on there, make sure to do those. Now, instructor information. My name is Paul Yost. I am a associate professor in the kind of gaming and simulation engineering game programming degree. I also teach in the computer engineering degree, and the office hours are going to be held online. I can do like a video conference through Zoom or whatever, or you can make an appointment and I can meet with you. And my office, if you need it, is in the Advanced Technology Center, 307. That's all the way on the 3rd floor. If you go to where the faculty office is, right when you get off the elevator there's a door. If you're facing the elevator, there's a door to the right of that. If you just go through there, walk all the way around the back, my office is right around behind that corner there. So if you need to set up an appointment, come and see me. That phone number that I have listed there is my mobile number. So feel free to send me a text message or give me a call if you're having problems. If you do give a call, maybe text message me first. Send me a text that says who you are and what class you're in. Because if I get random calls, I tend not to answer. And the other option will be to leave me a voicemail when you call me, and I'll get back in touch with you. Another really good way to get a hold of me is to send me an email, either at pyost@shawnee.edu or paul.wyost@gmail. The difference between those, this is my university one, this is my just generic Gmail address. The Gmail address will go directly to my phone. I don't always check the Shawnee one when I'm out running around and doing things. So if you want something that's urgent, send an email to my Gmail or send me a text message or call. If you have something, the university likes to keep all of the correspondence in their system. So you may want to send that message to the Shawnee domain. It's easy. I'm in the directory on there. So either of those is okay. And if you really want to, you could CC both of those, like send one here and there, and I'll be sure to get that and get back to you. All right, textbooks. There's not a book for this class. All of the information you'll need will be provided. There are, however, some good books. So if you feel like you're the type of person that learns better with a book or likes to have a book for reference or would like to kind of read ahead and get ahead on the stuff and have that in your library, let me know. There are some really good books that I think are good to have. The only reason we're not using a book in this class is the way we cover things is a little bit different than you'll find in books, and we don't really, the assignments or programming assignments that I will give you, the quizzes are things that I'll make up, so there's not really like a textbook that we're going to be using. Now, everything though, all the material that I present will be posted to the course site, so you don't have to worry about not having access to that or anything like that. All right, now let's spend a little bit of time looking through this course description. And this course description is not exactly the one that's in the catalog. This is more of my exposition on that. So let's read through that. It says a computer requires software to be useful for something. And that is clearly true, that you have to have software that runs on that computer to make it do something. Otherwise, it's just a lump of metal and silicon and wires and other things. So some software is application software. Some software is at a lower level than the application level. So systems programming is the activity of programming this lower level software for a computer system. The primary distinguishing characteristics of systems programming when compared to application programming is that application programming aims to produce software which provides a service directly to the user, whereas systems programming aims to produce software and software platforms provide a service to other software, sit directly on some hardware platform, are performance constrained, or most commonly some combination of those. So let's go and pause there for a second and talk about what we just said there. So a program that an end user would use would be an application. So something like, I don't know, you might think of that as being something like a web browser or even a video game, or maybe something like Zoom, like a conferencing application. So those things themselves are kind of application level, but in order for those to work, they have to interact with something lower level. They have to interact with a network subsystem. In the case of Zoom, they have to interact with a network subsystem. In the case of a web browser, they have to, in the case of a video game, they have to get input from a keyboard. They have to get input from a mouse. So that lower level stuff is either at the operating system level, or if you're writing something that sits more directly on the hardware, like in an embedded system, then you're writing code that sits directly on the processor, talks directly to sensors or other components to get them to do what it needs to do, gets the stuff directly from that hardware in some way. And one of the reasons why, another reason to do systems programming or low-level programming is where you want something to be really fast or interact directly with hardware components of some form. And let's go ahead and continue on now to the next paragraph. So systems programming requires a great degree of hardware awareness, and its goal is to achieve efficient use of available resources, either because the software itself is performance critical, like a video game. You have to have a good frame rate. You have to have a good or low latency for something like VR or anything like that, where you press a key, you need to have an immediate reaction, or because even small efficiency improvements are directly related to improved experience for the user or monetary savings for the provider in something like embedded systems. So in those cases, we want to squeeze power or performance out of the system that we're using, or we want to design the system to be as low cost as possible given the performance we need for an application, because that could mean a longer battery life, that could mean a lower cost, it could mean a longer battery life and a lower cost. But the idea there is that we want to talk to the computer and use it at its level because we care about performance and access to kind of those low-level hardware things. Now, continuing on, it says, as such, for this class we will be using C language, since C is a high-performance mid-level language that was designed specifically for high-performance systems programming. So C language is used heavily by software that must provide high performance and is much faster, for example, than Java, Python, or C#. And then toward the end of the semester, we're also going to talk a little bit about C++. I'm going to introduce you to that. It's not going to be a full course in C++, but I want you to be able to distinguish between C and C++. They're closely related to each other. We'll talk about how they're related. But the idea there is going to be that we are going to have a pretty comprehensive coverage of C language. You should be very proficient with that, and you're going to have an introduction to C++, and we're going to write some code in that, and you're going to hopefully understand the difference between the two. Now, by the end of the course, you'll be proficient with the C programming language. You'll be able to understand and write non-trivial pieces of software. So that's what our goal is for this semester, is you're going to learn C language, you're going to be able to write some sophisticated programs in it, and you're going to also be at least exposed to C++ and know something about that. Okay, attendance. I'm going to go ahead and pause for just a second. We're going to talk about attendance shortly, so give me 1 second, and then we'll talk about the rest of the stuff that's on the syllabus. Okay, so attendance, well, obviously that's different than usual, but I don't really have an attendance policy anyway, but in this case, it's going to be up to you to be responsible for watching the videos, making sure you know when the quizzes are, making sure you know when the assignments are, and making sure you know when the exams are. Now, so there's not really, I'm not going to be giving points for attendance. You get points by learning the stuff and showing that to me. Speaking of my grading system, the grading system, this says tentative, but this is what we're going to do. It's 40% is the work that you do, meaning the homework assignments, the programming projects, the quizzes that I give. So that's the largest percentage, is the essentially those things like the programs you write. And in this class, we're going to have a lot of it be programming assignments, a little bit of quizzes as well that you check in and do, and then toward the end of the semester, those programming assignments or projects will get a little bit larger, a little more comprehensive, or a little more complicated. And then we have 2 exams. So there's only 2 exams in this class. One of them is the midterm, which is worth 25%, and then one is the final exam, which is by nature has to be comprehensive. So it'll cover everything that was on the midterm plus everything we covered after the midterm. It'll tend to focus on the things toward the second half of the semester, but notice there are just 2 exams. Now, With the exams, I'll announce them. The midterm will be announced at least a week before it's given, and I'll post a study guide and maybe some practice questions as well on the course site. So look for that. There is one other, and the final exam will be given when it says on the schedule for your particular class time. So there's an official final exam schedule. The exam will be when that says it is. These exams will be face-to-face, so that's the only time really we'll probably be in the same classroom together, is to do those 2 exams, and we'll make sure that we follow social distancing and that everybody has masks and that that's done in a safe way. But my plan right now is to have the exams face-to-face. That could change, but that's my plan right now. Now, there is one other rule. You have to pass the final exam to pass the class. And the reason for that is the final exam is kind of my way of saying, what did you learn, and can you show me that you learned what you need to go on from this class? And as we'll see here in a second, that if you did all of the homework and programs and quizzes and you understood the material to at least a moderate level of understanding, then you'll do fine on passing that final exam. All right, the grading scale is listed here. I'm not going to go into too much depth and read the whole thing for you, but notice it says it'll be no worse than that, meaning that I could curve to improve your grade, but I'll never curve to hurt your grade. So in other words, if everybody in this class does really well and gets grades between 90 and 100, so somewhere up here, I'll never take that and then push it down or stretch it so that the people that had A minuses now are getting C's because I thought there were too many A's in the class. But I might take it and slide it up slightly to improve things. But I've been teaching for a long time. I've taught this subject material for a long time. And so it'll usually come out pretty close within 1 or 2 points, but I'll never pull it down. I'll always push it up to help you. Now, again, you have to get that final passing grade. So you have to do better than essentially 60.5, because I'll round up. So 60.5 or higher. And in order to, on the final exam, to pass the class. All right, couple rules. The disruption one probably doesn't matter too much unless we do the Blackboard Collaborate sessions, but the cheating one does. So I don't like intellectual dishonesty. We're here to learn stuff. We're here to, and I'm here to honestly grade you and honestly help you. So don't try to turn in some work that's not yours, or search for on the internet, Google some program and turn in something that you didn't write yourself. You can talk to each other. You can work together. You can get on Discord or whatever and talk with your friends and the other people you know and get help. But what I want you, when you turn something in, I want to know that you understand what you turned in and that it's your work. Don't hire somebody on rentacoder.com or get on Stack Exchange and post your assignment. So the idea here is I want you to learn, and I want to grade you on what you've learned. So don't try to be intellectually dishonest. That has severe consequences in science and technology related areas when people are dishonest. And so just don't do it, because I'll be unhappy. And if I'm unhappy, you're going to be unhappy with the way that I deal with that misconduct. Okay, programming assignments. The programming assignments, essentially, there's a bunch of words here, but really, when I give you an assignment, it'll have a due date. If there is no due date, it's due by the last regularly scheduled class of the semester. Almost all of them are going to have due dates on them, but just submit them on Blackboard before the due date. All of them will be online submissions to turn them in. I think everybody in this class should be aware of how Blackboard works and how you submit your assignments and things like that. Now, one thing to note is that I do require you to document your code. In other words, I want you to have like a comment block at the top of your code that has your name, the assignment number, maybe if it has a subpart of the assignment, maybe a little description of what it is, what class, what section it is. So, and we'll talk about the details of that later on, but make sure you put that in there so when I download those files, I know whose work goes with who. And I can get it graded. Otherwise, I might not know whose it is, and I won't be able to give you the grade on that that you would otherwise have earned. All right, now don't send me your assignments via email or Facebook Messenger or anything like that unless you've talked to me ahead of time and made those arrangements. If your Blackboard account is messed up and it's not working, send me a text message, give me a call, let me know that ahead of time, and then I'll make sure to make some sort of alternate arrangements. But I'd prefer to keep all the assignment submissions on Blackboard. It makes it easier because the gradebook is on there. It makes it easier because then I don't have to move things from one machine or one account to another account. It just all around is easier to do it on there. So do that, and I won't accept them if they just show up in my email. I'll figure you're sending me something not to be graded. So just if there's something wrong with your Blackboard account and you can't submit it for some reason, let me know and I'll make arrangements with you. Okay, exams and quizzes we already talked about. The exam, the midterm, will be announced at least 1 week before it's given. I won't give a makeup exam unless you have made prior arrangements with me. So for example, if you have some health emergency or a family emergency, or you're on a sports team or something like that, let me know ahead of time and I can make arrangements to give that another time. Now the quizzes won't necessarily be announced. Just expect that at the end of every class session, or the beginning of every class session, there could be a quiz that gets posted, and you can take that quiz and submit the results of that on Blackboard. But the midterm will be announced at least a week before I give it. Quizzes will not be. So therefore, since the quizzes will all be on Blackboard, and it's your responsibility to check that and make sure of that, I won't give makeup quizzes unless you have some valid excused absence or reason why, like you have a doctor's note, you were sick, you had some family emergency, something like that. Okay. The ADA statement, if you have some sort of a need for an accommodation, then based on some documented disability, then the first thing you should do is contact the coordinator in the Office of Accessibility Services in Hatcher Hall. I put the number there for you if you need to call that. And so I want you to make sure that we get any accommodation handled, but in order to do that, you have to communicate with me, you have to communicate with that Office of Accessibility Services, and they'll work with me to make sure that we accommodate that. So if you need, I don't know, like a final exam in a larger font because you have vision problems, or you need the final exam to be taken in a different environment, or you need some sort of a electronic form of the final exam so that a document reader can be used with it, anything like that, I'll work with you on that, but make sure that you go through the proper channels to do that so that we can do things the right way. So in other words, don't just show up for the midterm and say, I can't take this test because of this disability. Make sure to go through the proper channels. Make sure to do that before the test and before the exams. Do that. Most of the rest of the stuff, the assignments, will be posted on the course page. The quizzes will be posted on the course page. So if you can read that and access that, you can do that. And most of the assignments and quizzes will have a little bit of time that you can work on it. So feel, but if you do need something on those, let me know in that case too. But feel free to contact me and discuss any of those concerns you might have. All right, so that's really it for the syllabus. So let's switch back here to the slides temporarily. All right, so we looked at the syllabus. And in looking at that syllabus, we went over kind of those course expectations. We talked a little bit about what systems programming is. We're going to talk a little more about that as well. But the next thing that I want to discuss here is kind of systems programming in a little more detail. But before we do that, I want to mention my teaching philosophy for a second. And my teaching philosophy is the kind of verb phrase to teach really doesn't make a whole lot of sense. It's really gets things a little bit backwards. And that, why would I say that? Why would somebody who's a professor say that to teach doesn't make a whole lot of sense? And the reason for that is that that puts the active part of it on me, that I'm just going to teach you something and you're just going to passively learn it. But really, to learn something, especially something like systems programming, that's a skill and there's knowledge involved, and it's you have to practice it to get better at it, and we're going to be doing assignments. In order to do that, you're going to have to be the active one. So you're going to have to learn. And my job isn't to like force something on you and make you learn it. My job is to be kind of like a guru or a Sherpa and kind of lead you up this mountain in the way that makes it as easy as possible for you to learn what you need to learn. So my job is also to kind of grade how well you learned that. And I take those responsibilities very seriously. But for that to work, you're going to have to be active. You're going to have to spend some time and effort. You're going to have to put in the work on the assignments. You're going to have to actively ask questions if you need help with something. And I really wish we were able to teach or be in the same room together to do this. I think it's a lot easier to do it that way. But unfortunately, the world is what it is right now. So we're going to make the best of it. And as long as you put in a little bit of extra effort on communicating with me, I'll put in whatever effort it takes to come and meet with you if you need me to, or otherwise make sure that we're all on the same page when we do this stuff. All right, now moving on to systems programming. And what we're going to do is we're going to just talk about this just for a couple minutes here, and then we're going to stop and then come back and do a little more. But systems programming is really just a specific kind of computer programming, which at this point, for you to be in this class, you have to have done some computer programming. So this class is not going to be an intro to programming class. I assume that everybody has written programs and written for loops and know what variables are and things like that. We are going to kind of take a step back and go through some of that again, just to fill in any gaps in case you have some sort of confusion about it. But this is not an intro to programming class. This is a systems programming class. And what that means specifically is it's a different kind of programming than other kinds of programming. And the reason for that is it's lower level, meaning that we're going to be interacting at a level in the computer system that is different than what you will have experienced in something like, for example, Python. The language is going to be different. It's going to give us more power. It's going to give us more control over things. But we're going to have to be careful how we use that, because that additional power and control and direct interaction with something more at the hardware level, we have to be a little more careful what we're doing. So that more power, though, gives us more direct control of the hardware. So we can write programs that more specifically control what the processor does, what happens in memory. We'll talk about those in just a second. And it also requires different languages and tools in order to do that, and that's why we're using C language for this class. That C language is a tool that was specifically created for systems programming. It's a language that was created specifically for systems programming, and it really is one of the most, still one of the most popular, sought-after languages, especially for something where you need that kind of power and that kind of control over things. And we'll talk more about that here in a little bit. But that's the idea of what we're going to do today, is we're going to dig into that. And in order to make more sense of that, we're going to first start off with, since we're going to be directly controlling or interacting with the components of this computer system, the first thing we do, we're going to talk about today, we're going to take a little break. I'm going to pause the video. And then after that break, what I want to do is we're going to dig into kind of what is the computer system, what is it, how does it work, how does it behave, and we're going to do some of that. And then we're going to start digging into C language next class. We're going to spend a little more time on how the computer works and then dig into C language in the next class. So we'll go and stop there. But what I want you to do is look over the syllabus. If you have any questions on anything, let me know. If you have any concerns about anything, let me know. But other than that, we'll take a quick break and we'll come back for part 2 of this class 1.